Okay, in this video we're going to look at some more examples of solving a system of linear equations by substitution. So remember that the very first thing that we need is we need to have one of the equations solved for one of the variables. Now we've been using y all along, but we will see at least one example in this set of problems where we'll have to solve for x instead, or solving for x will be easier than solving for y. So you can solve for either x or for y, it doesn't matter. Now, first thing that I need to do is take one of my equations. I'll take the first equation. X plus y is equal to negative 2. I can simply subtract x from both sides and I end up with y is equal to negative x minus 2. I'm going to begin with my first equation by substituting this into the second equation, since I've already used the first equation. Negative 3 times x plus y. And in place of y, I'm going to substitute negative x minus 2. I have negative 3x. Now again, what confuses a lot of students when there's no number out front, in front of the parentheses, we can put a 1 there and think of this as multiplying 1 times negative x, which is negative x, 1 times negative 2, which is negative 2, and then that is equal to 6. Combining like terms, I get negative 4x minus 2 equals 6. I'm going to add 2 to both sides, and I end up with negative 4x is equal to 8. Dividing by negative 4, x is equal to negative 2. The next thing that I want to do then is now to take that solution, x equals negative 2, and substitute it into either equation at this point. So the easiest one to use might be x plus y is equal to negative 2. And I know that x is negative 2. Negative 2 plus y equals negative 2. I'm going to add 2 to both sides. When I do, I have y is equal to 0, telling me that my ordered pair solution is negative 2, comma 0. Right? The third thing that I'm going to do is now take the second equation. So you can almost think of this as we're going to use both equations twice. First, we use the first equation to solve for y. We could have solved for x or for y. It doesn't matter. Then we're going to take the other equation that we hadn't used yet, in this case the second, plug in the new definition for y. Then we're going to go back to the first equation, but it doesn't matter whether you use the first or second here. What does matter is when you go to check, you're going to use whichever one you haven't used yet. And so now we have negative 3x plus y is equal to 6. And I'm going to substitute x is negative 2, y is 0, and that should be equal to 6. Oops, I'm missing a negative 3. It should be negative 3 times x, which is negative 2, and that gives me positive 6 plus 0 is equal to 6. 6 equals 6, and that is a true statement. So my solution is x is negative 2, y is 0. We'll go on to problem number 5. In problem number 5, again, I have two equations. I need to solve one of those equations for either x or for y, and I will work with the first one, starting out negative x plus y equals negative 4. Adding x, this time gives me y equals x minus 4. So I've used the first equation, now I'm going to go to the second equation. Second equation says 4x minus y is equal to 10. In place of y, in parentheses, not changing the minus sign out front, I'm going to put x minus 4. That all should equal 10. Remember, you can think of that being a negative 1 in front of the parentheses, so that I'm going to multiply negative 1 times x, negative x. Negative 1 times 4, positive 4, and that's equal to 10. 4x minus x is 3x, plus 4 is equal to 10. Subtracting 4 on each side, and I get 3x is equal to 6. Dividing both sides by 3, and I got x is equal to 2. The next thing that I'm going to do, I've used the first equation, the second equation. I can use either one now, whichever I choose, the easiest one. I'll just use the first. Negative x plus y equals negative 4. In place of x, I'm going to put 2 plus y equals negative 4. I'm going to add 2 on both sides, and when I do, I get y is equal to negative 2, making my ordered pair solution 2 comma negative 2. I just have to check at this point. I've used the first equation, then the second, then the first again. Now I'm going to use the second equation. 4x minus y is equal to 10. It says that x should be 4, then minus y, but y is negative 2, so you can't just write minus 2, it's minus negative 2, and that's going to equal 10. 8 plus 2 is equal to 10, and so that checks, and I have my ordered pair solution to be 2 and negative 2. Okay, we'll go on to problem number 6. Okay, problem number 6. Again, we need to solve one of the equations for y or x. In this case, only the y's are easy to solve for without fractions. And we can use either one, but I'll just use the first one if that one is as easy as the other one will be. I have 2x minus y equals negative 5. Now, I'm going to subtract 2x on both sides. You have to be really careful here because you have a negative sign in front of the y. Giving me negative y is negative 2x minus 5. Then I'm going to divide everything by negative 1. And when I do, I end up with y is equal to 2x. Negative 2 over negative 1 is positive 2. Negative 5 over negative 1 is positive 5, giving me y is equal to 2x plus 5. So I use the first equation. Now I'm going to use the second equation. Second equation says 3x minus y equals 1. In place of y, remember, you still have to put the minus sign there. 2x plus 5, and that's equal to 1. We can think of a negative 1 there in front. 3x minus 2x minus 5 equals 1. 3x minus 2x is x minus 5 equals 1. Add 6 to both sides. Sorry, got ahead of myself. Add 5 to both sides. And what I end up with on the right is 6. Okay, first part is done. Second part, I've used the first equation, then used the second equation. I can use either equation now to plug in x equals 6. I'll go ahead and use the first one. Doesn't matter. 2x minus y is equal to negative 5. If x is 6, then I end up with 2 times 6, which is 12, minus y equals negative 5. and I can subtract 12 on both sides. I get negative y is negative 17. Divide by negative 1, divide by negative 1, y is equal to 17. When I do, now my ordered pair solution then would be x is 6, y is 17, and I need to test that out. I use the first equation, then the second, then the first. Now I'll use the second. Again, the order doesn't really matter, but if you use the first one first, then you use the second one to get x. If you use the second one next, the first one next, you're going to use the second one to check. So 3x minus y should be equal to 1. So it tells me that x is 6 minus y, which is 17. 3 times 6 is 18 minus 17, and that 1 is equal to 1, and it checks. So my ordered pair solution is indeed 6, 17. Okay, then number 7, the final problem in this set. Now you can see I don't have a y by itself that's easy to solve for. I do have an x that's by itself, and I'm going to solve for x in this case instead of y. And I can do that simply by adding 2y to both sides so that I get x is equal to 2y plus 7. Now I use the first equation, now I'll use the second. 3x minus 2y equals 3. In place of x this time, I'm going to put 2y plus 7, then minus 2y equals 3. Distribute, I get 6y plus 21 minus 2y equals 3. First, I'm going to combine like terms. 4y plus 21 is equal to 3. Subtracting 21 on both sides, I'm going to end up with 4y is equal to negative 18. Dividing by 4, and I get y is equal to negative 18 fourths, which is negative 9 halves, or which is negative 4.5. Doesn't really matter to me which one of those we use at that point. Next, I use the first equation, then the second. I'm going to pick either equation to plug in y is equal to negative 4.5. Let's use the first. X minus 2y is equal to 7. X minus 2, I said y was negative 4.5, and that's equal to 7. Distributing, I get negative 2 times negative 4.5 is positive 9. X plus 9 equals 7. Subtracting 9 on both sides, and I get x is equal to 2. Negative 2. All right, so if I'm correct here, my x coordinate for this problem is negative 2, and my y coordinate is negative 4.5. I just have to do a test. I've used the first equation, the second, then the first again. Now I'm going to use 3x minus 2y equals 3. 3 times negative 2 minus 2 times negative 4.5 equals 3. 3 times negative 2 is negative 6. Negative 2 times negative 4.5 is positive 9. Negative 6 plus 9 is 3, and that checks, so my ordered pair solution is indeed negative 2 comma negative 4.5, and so that will do it for this video as